Cartesian sign convention mirror. So here, all the distances are measured from the pole of the mirror. This is the first point. Okay, the pole is the origin. If the distance is measured along the direction of the incident ray, then it is positive. Suppose if we measure the distance from the pole in the direction opposite to the direction of the incident ray, then the distance is taken as negative. So let us learn by the diagram. Direction of incident ray that goes from left to right. Here we have a concave mirror. So there is an object, a light ray goes and hits the mirror, get reflected and forms an image. Now we have to measure all the distance from the pole. The first distance is the focal length that we measure in the direction opposite to the incident ray. So it must be negative, minus f. Then we measure the distance of the image that's also in the direction opposite to the incident ray. So it is minus v. Similarly, the center of curvature equals radius of curvature minus r. Then object distance, that's also in the direction opposite to the incident ray, it is minus u. So if you consider a concave mirror, then the minus focal length and minus radius of curvature are permanent. That means for a concave mirror, the focal length is always negative, the radius of curvature is always negative. Then the object distance supposed to be in front of the mirror, it cannot be behind the mirror. So this also should be negative, right? The image distance, only one case it can be positive when the object is placed within the F, then you get a virtual image behind the mirror. In that case, right, the V will be positive, right, in only one case. So let us go for the second case. Direction of incident ray goes from right to left. Here you have a convex mirror. Then there is a focus. Here there is a converging ray, right, that forms a virtual object. Then this rays get reflected and forms a image. Now let us measure the distance of the focal length. It is measured in the direction of the incident ray, so it is plus f. Then object distance, it is plus f. It is a converging ray, right? So the object is virtual, the image is real. Suppose there is a object and there is a ray goes. This is what we call diverging ray. This object is real and the ray will be getting reflected in this direction and it forms a virtual image. Here, this is a virtual image. Right, okay. Let us not have all this in our case now. Let us rub this. Fine. So here, the object distance is positive because it is measured in the direction of incident ray. The image distance is measured in the direction opposite to the incident ray. So it is minus v. So the center of curvature is measured along the direction of the incident ray. So it is plus r. So for a convex lens, the focal length is always positive and the radius of curvature is always positive. The distance measured above the principal axis is positive. Similarly, the distance measured below the principal axis is negative. So here you have a concave mirror. There is an object upright. So it is measured plus h1. So this object is just, okay, forms an image. In the inverted image, it is below the principal axis, which is taken as negative. Right? Let's go for, so the M is negative. The magnification is H2 by H1, so minus H2 by H1, so it becomes negative. Right? Let us go for the second case, concave mirror. Here the object is placed within the focus. Then it will form a virtual erect image behind the mirror. So both are upright above the principal axis, both are positive, so magnification is positive. Let us go for a convex mirror. Wherever you place the object in front of the pole, It is plus H1, it is erect, it forms a virtual erect image within that is behind the convex mirror. So it is also positive. M is positive, right? Suppose we go for the next case. M is positive. Suppose in a problem, right, it's given the magnification is positive. It can be three type of mirror. It can be a concave mirror, or it can be a plane mirror, or it can be a convex mirror, right? In first case, concave mirror, right? In concave mirror, we have an object. This has to be within the focus. It forms a erect, enlarged image behind the mirror. So the M is greater than 1, right? H2 is greater than H1, so M is greater than 1. So in the case of plane mirror, the object forms an image which is of the same size. The image is same size, same height of the object. So M equals 1, right? And the third, so object which is small, which forms a image behind this convex mirror, which is enlarged. So M is negative. So in all these three cases, one is very sure. What is that? If M is positive, the image is virtual, the image is erect. I repeat, if the magnification is positive, two things gets confirmed. One is the image is erect. The second is the image is virtual. Let us go for the second one. The M is negative. If magnification is given negative, then the mirror is a concave mirror. So there is no need to go for a plane mirror. There is no need to go for a convex mirror and all. If M is given negative, then it has to be a concave mirror. Then let us deal this for three cases. One, the object is beyond center of curvature. When it is there beyond the center of curvature, then it forms a image within center of curvature and focus. In this case, the image is smaller than the object and inverted. So, in the second case, in the first case, M is less than -1. In the second case, the object is at the center of curvature. So, it forms an image at the center of curvature, but inverted with the same height. So, M is -1. The negative indicate the image is inverted. One indicate the size is the same one. So let us go for the last one. So here the F is less than. So the object is within center of curvature and focus. Then it forms an image beyond the center of curvature, enlarged. So M will be greater than -1. Here I have made a mistake. Here it must be -1, right? It must be -1. It is wrong, right? It is inverted, no, so it is wrong. So M is negative means it has to be a concave mirror. Two things gets confirmed. One is the image is inverted, right? And it must be real. Get your sleep. Your brain will thank you. Follow my channel, children. Thank you.